Action potential generation. The plasma membrane of a neuron separates the extracellular space from the intracellular space. Sodium ions are found in high concentration outside of the cell, whereas potassium ions are found in high concentration inside of the cell. Voltage-gated sodium channels, sodium-potassium ATPase pumps, and voltage-gated potassium channels are found embedded in the plasma membrane of the neuron. To initiate an action potential, a stimulus causes a wave of positive charge to reach voltage-gated sodium channels on the neuron membrane. The increase in positive charge causes the voltage-gated sodium channels to open. Positively charged sodium ions flood into the neuron following their concentration gradient. This causes the inside of the membrane near to the open sodium channel to become more positively charged. This process is the depolarization of the cell membrane. The buildup of positive charge on the inside of the membrane eventually causes the voltage-gated sodium channels to close. At the same time, voltage-gated potassium channels open, since they open only when the inside of the membrane is at its maximum positive charge. Positively charged potassium ions flow rapidly out of the neuron following their concentration gradient. This decreases the level of positive charge on the inside surface of the neuron. This return of the membrane to resting levels of negative charge is called repolarization. Once the region of the membrane has been fully repolarized, the potassium channels close. A sodium-potassium pump uses ATP energy to restore the concentration gradients of potassium and sodium to their resting values. Let's summarize the processes of generating an action potential. The resting potential is the membrane potential of a neuron when it is at rest. The resting potential is well below zero. To initiate an action potential, a stimulus causes a slight depolarization or increase in positive charge. If the stimulus is strong enough to cause the membrane potential to reach a certain threshold, the action potential will begin. In the rising phase of an action potential, voltage-gated sodium channels open, and sodium ions flow into the cell. This causes voltage to increase inside the cell. During the falling phase of the action potential, voltage-gated sodium channels close, voltage-gated potassium channels open. The opening of the potassium channels causes potassium ions to diffuse out of the cell rapidly, causing a sharp decrease in voltage. During the recovery phase, a sodium-potassium ATPase pump restores the resting potential. Sodium-potassium ATPase pumps pump 2 sodium ions in and 3 potassium ions out of the neuron. Sodium-potassium ATPase pumps require ATP to function.